Let's go to page 68 and start with number 77. So it says if line y equal to mx plus 1 intersect the ellipse x squared plus 4y squared equal to 1 at exactly once, find m squared. Okay, so if they intersect at one point, that means that you're solving the equation. So you're solving the two equations together. Okay. So to solve the two equations, this is a substitution type of equation, so you can substitute this into here. So you're going to get x squared plus 4. Now the y is mx plus 1 squared equal to 1. Okay, so go and multiply out. 4 times m squared x squared plus 2mx plus 1 equal to 1. Okay, and then go and distribute out. So this will be 4m squared x squared plus 8mx plus 4 equal to 1. And let's go ahead and minus 1 on both sides and combine the like terms. Okay, so these two terms we have 4m squared minus plus 1 times x squared, and this would be 8mx minus 1 on both sides would be plus 3 equal to 0. Okay. Okay, now when you have the quadratic formula, you got x equal to negative b plus or minus square root of b squared minus 4ac over 2a. Now since they intersect once, that means you only have one solution. So that means you can have a plus or minus. Okay, that means this part equal to 0. Okay, so you got x equal to negative b over 2a. Again, you only intersect once. Okay. Now if it intersect twice, then you will have the plus or minus. So again, if it intersect only once, means only get one set of solutions. So therefore, there would be no plus or minus. Okay. And so from here, so you have the square root of b squared minus 4ac equal to 0. And you have that. Okay. And so let's go and solve this part over here. So you have b squared minus 4ac equal to 0. So the b squared is this part over here. So it'd be 8m squared minus 4a is 4m squared plus 1, and c is 3. Okay, so you can intersect only once, means this part equal to 0. So you can solve that. And now the reason we don't deal with this because we're not interested in x. We try to solve for m squared. So this is not going to help as much. So that's why we use this one. Okay, so working this out, so you're going to get 64m squared minus 16m squared minus this at the times to be 12, so it'll be 48. So 3 times 4 is 12 times 4 is 48 minus 12 equal to 0. Okay, and you can simplify this. So you get 16m squared, move this over, so equal to 12, and divide by 16. So you got m squared equal to 3 over 4, and that's it. Okay. Okay. Next one. So let's go to 78. It says find the equation in rectangular coordinates of the curve whose product equation is, so you have r equal to 2 secant theta plus cosine theta. Okay, so first we need to change this into sine or cosine. So r equal to 2, secant is 1 over cosine, so this would become cosine theta plus cosine theta. And next, let's go and get rid of the fraction. So multiply by cosine theta. So you're going to get r cosine theta equal to 2 plus cosine square theta. Okay. And now to convert this into rectangular, since this is the cosine square theta, you need to multiply by r square, because you need to have a r cosine theta. Okay, so multiply by r square. Now you don't want to multiply, so keep that as that. So you're going to have r square, and you have r cosine theta equal to 2r square plus r square cosine square theta. Okay. And so this part over here, so r squared is x squared plus y squared from your Pythagorean theorem. R cosine theta, so again, if you remember from your, so this is r, this is theta. Okay, so this is r cosine theta, this is r sine theta. Okay, so r cosine theta is also equal to x. Okay, so this would be the x, and again from your Pythagorean theorem. Okay, so x squared plus y squared equal to r squared, so that's where it came from. And so this would be 2 times x squared plus y squared. So r cosine theta is x, so this would be x squared. Okay, so go ahead and multiply these things out. So you're going to get x cubed plus xy squared equal to 2x squared plus 2y squared plus x squared. And go and move everything to this side. Okay, so this and this would be 3, right? So when you move over, so you get x cubed plus xy squared. So you move this over would be minus 3x squared. Move this over would be minus 2y squared equal to 0. Okay, and that's it. Okay, let's go to 79. It said a circle has the same center as ellipse. Okay. Okay, so you have ellipse, and so the center is over here, and you have a circle with the same center. And you pass through the force at F1 and F2, so this is the F1, this would be the F2. And it says the two curves intersect at 2 points. So again, so this is kind of have to be careful. It talks about the curve, not the shape. So the curve, it intersects at 2 points. Okay. So again, the curve is just talking about this part over here. Okay. And let P be any point of intersection. So if you call this point P, this would be the xy. Okay. If the major axis of the ellipse have length of 15, okay. Okay, so that means, remember the differential ellipse is so d1 plus d2 equal to the major axis equal to 2a, and this is equal to 15. Okay. And the area, so this area, so area of that triangle, so P F1 F2 is equal to 26. Compute the distance between the four sides. So you're looking for this distance. So basically you're looking for the diameter. Okay, so you're looking for diameter of the circle. Okay, so you can just read the poem and understand what we're talking about. Okay. So in this case, instead of using the xy, okay, let's just go ahead and call this x, call this y, okay? Because since this point is on the circle and this is the diameter, so this is a right triangle, so this will be your base and the height, okay? Okay, so from here, the 2a, so again from so your d1 plus d2, that's your x and the y, right? So x plus y equal to 15. Right? Again, d1 is x, d2 is y. So d1 plus d2 is x plus y equal to 15. And from here, the area equal to 1/2 base times height, so it would be x times y, okay? And this is equal to 26. Again, the area of the triangle is 1/2 base times height, so it's 1/2 x times y, and that's equal to 26. Okay, so you move it over, so you got xy equal to 52, and you got x plus y equal to 15. Okay. And so we're looking for this over here, okay? So we're looking for the diameter. So diameter, the F1, F2, because this is a right triangle, so this will be hypotenuse. So this will equal to square root of x squared plus y squared. So that's what we're looking for, okay? Okay, so what we're going to do is, again, so solve for x and y. Okay, what we can do is we're going to use the trick we learned from before. So we're going to square this equation. So you get x squared plus 2xy plus y squared equal to 225. Okay, and again, because we're looking for this, so we're going to keep these. So we're going to minus the 2xy. Okay, so we got x squared plus y squared equal to 225 minus 2xy, but we know what xy is. Xy is 52, so it'll be minus 2 times 52. Okay, so you can substitute this into here. Okay. Into here. Okay, so x squared plus y squared equal to 225 minus 104. So x squared plus y squared equal to 121. So the square root of that will equal to 11, and that's what we're looking for, right? So F1, F2 equal to 11. Okay, let's go to the next one. Okay, number 80 is that a point P lies in the same plane as the given square of the side 1. Okay. Okay, so let's go ahead and make a side 1. First, let's get a square. And let's go and label the point A, B, C, D. Okay, and we're going to call this point 0, 0. Okay, so you have a square with side length of 1. So if you make this equal to 0, 0, make this as origin. So this would be 1, 0. This would be 1, 1. And this point would be 0, 1. Okay, and so you have a point out here somewhere. Okay, and this is point P. Okay, so it'd be xy. Okay, so from here, you're also giving you that the distance PA is equal to U, PB equal to V, PC equal to W. Okay. And you're also giving that U squared plus V squared equal to W squared. Okay. Okay, so U is from P to A. Okay. So that's AP squared. V is PB squared, and this is equal to PC squared. Okay, now by using the distance formula, so distance formula from AP square will give you would be just would be x minus 0 squared plus y minus 1 squared. Okay. Now normally distance we take the square root, right? But because the square we cancel out the square root, so it would be just that. Now PB would be just x minus 0 squared plus y minus 0 squared. Okay. And again, because it's square, so square we cancel out the square root, so we don't need a square root for the distance. And the C would be x minus 1 squared plus y minus 0 squared. Okay? Again, normally we take the square root, but because of the square, it cancels out the square root. Okay, so let's go ahead and simplify all these. Okay, so from here you're going to get x squared. From this you get plus y squared minus 2y plus 1 plus, this will give me x squared, this will be plus y squared equal to, this will be x squared minus 2x plus 1, this will be plus y squared. Okay. So let's go and simplify things a little bit. Well, first, you got x squared and x squared, so you can minus x squared, so this will cancel out. And I'm going to minus the y squared, so this will cancel out. And I'm going to plus 2x, and I'm going to move the, I'm going to minus the 1, you have 1 and 1, so minus 1, it cancels out. Okay, so this cancels out. So we have x squared plus 2x plus y squared minus 2y equal to 0. Okay, so this is a circle. Okay, so this is equation for a circle. So I'm going to complete the square. So x squared plus 2x plus y squared minus 2y equal to 0. So from here I can get the template ready. So I get x plus 1. Okay. So I need to plus 1 over here. And this one I need to get y minus 1. So I need to plus 1 also, so plus 1. So this will equal to 2. So this is a circle. So that means the P, the point P with a random point P with the coordinate x, y is a circle. Okay, it's a circle with center at, so center is going to be at negative 1, 1, and the radius will be equal to square root of 2. Okay. Okay, so now let's go back to over here. So center is going to be negative 1, 1. So it'll be negative 1, 1. So it's going to be right over here. So negative 1, 1. So this is the center of the circle. Okay. Now, since this, if you notice that this is the center of the circle, so the point P, the greater distance between P and D would be if it's on the opposite side of the diameter right over here. So the P need to be right over here to get the maximum distance. Okay, so greatest distance PD is on the opposite side. Okay, so your circle is going to be like really big. Okay, and oh wait. So the radius is square root of 2. So it's about 1 point. It's about right over here. Okay. 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 Let's see if we can find a circle that will fit. Looks like this about. Yeah. Okay, none of it's going to fit nicely, so I'm just going to draw a circle. Okay, there you go. Okay, so this is the point P. Okay, now, So so now you have to find the distance PD. Okay. So distance PD will equal to well, over here we know this is the radius. Okay. So the radius equal to square root of 2. I'm going to call this point O. Let's see. Okay. Okay, so PD will equal to from D to, let's go and call this point X. Okay, so the PD will equal to dx plus px. Okay, so again, so px plus the dx give you the PD. Okay, now dx, so the dx equal to 2, okay? Because remember the center coordinate over here is negative 1, 1, and this is 1, 1. So the distance is 2, okay? So PD equal to 2. Now px is the radius, so it be square root of 2. Okay? So you can look at your coordinates. So center is at negative 1, 1, and the D is at 1, 1. So from negative 1 to 1 is 2. So this distance is equal to 2. And so that's it. So maximum distance PD would be 2 plus square root of 2. Okay, let's go to 81. Okay, it says an ellipse is drawn with major axis and minor axis of length of 10 and 8. Okay, so if the major axis is 10, so it would be a 5 and 5, and the minor axis is 8, so it would be 4 and 4. So right away that's your 3, 4, 5 triangle. So right away your the focus would be a 3. Okay, focus would be a 3, and this would be a 2. Okay, and then a circle is drawn that is tangent to ellipse with no part. Okay, the focus is a center, so focus as a center, so it's going to draw a circle. Okay, and it's going to tangent to the ellipse and no parts outside. Okay, so the circle will have radius of 2. Okay, because this is 3, because this is a 5 and this is 3, so this would be a 2. So radius equal to 2. Okay, and compute the radius of the circle. Okay, so that's it. Okay, so you can just sketch it out. So the answer is very obvious. The radius will equal to 2. Okay, let's go to next one, number 82. The point intersection of xy equal to 12 and x squared plus y squared equal to 25 are joined in succession. What is the result of the figure? Okay, now if you were to sketch out the x times y equal to 12, it's going to be a hyperbola, and this is a circle. Okay. With a radius of 5. So center is going to be a 0, 0, and radius equal to 5. Okay, and so well, actually the circle is kind of big. Okay, but what you're going to get is you're going to get a rectangle. Okay, so my drawing is a little bit off, and this would be a 3, 4. But actually this would be 4, 3, and this would be a 3, 4. And this would be a negative 4, negative 3, and this would be a negative 3, negative 4. Okay, so it's going to be a rectangle. and you can check, right? 3 times 4 give you 12, 4 times 3 give you 12, okay? And again, and radius 5, so this would be a 5, 5, 5, 5, okay? And you also can prove that this is a rectangle because what happened, so you have a quadrilateral with diagonal bisecting each other and each part equal to 5. Okay, so this has to be a rectangle. Okay. Okay, let's go to the next one. Okay, number 83. A circle rests in the interior of the parabola with equation y equal to x squared. So that is tangent to parabola at 2 points. How much higher is the center of the circle than the point of tangency? Okay, well, first let's go and sketch that one out. Okay, so again, if you make the table, you sketch out. So when x equal to 0, you get y equal to 0. When x equal to 1, y equal to 1. When x equal to 2, y equal to 4. Okay, and do the symmetry on the other side. Okay, so you have the parabola, and then you have a circle kind of fit inside there. It's a random circle, so you don't know where it is. Okay, so just go and draw a circle temporary for now. And you're going to have a radius somewhere over here. And you've got point of tangency right over here. Okay, and because of symmetry, the center is going to be at 0, k. And this point is going to be x, y. And this point is going to be a negative x, y. Okay. Okay, so the equation of the circle will be x squared plus y minus k squared equal to r squared. Okay, and remember, y equal to x squared, right? Okay. So I'm going to substitute this into here. So y equal to x squared, so I get x squared minus k squared equal to r squared. And going to multiply out, so I got x squared plus x to the 4 minus 2x, 2k minus 2k x squared plus k squared equal to r squared. Okay, I'm going to move everything over, so I make it equal to 0 so I can solve using quadratic formula. So I get x squared. X to the 4, I put things in order, so x to the 4, that takes care of this one here, and plus, so this one and this one would be 1 minus 2k x squared plus, and I'm going to put this as a constant term, so it would be k squared minus r squared equal to 0. Okay, then I'm going to apply the quadratic formula using the x squared, right? Because this is x squared, x to the 4x. So I'm going to let x squared be like the variable I'm solving. Okay. Now, if you're not comfortable with this, you can let z equal to x squared, and you can solve for z. Okay, so same thing. So x squared equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay. And okay, so this has to equal to 0 because you got x squared equal to a number. So from x squared you get 2 answers already. So notice intersect at 2 points, right? Okay. So if you have plus or minus, you're going to get 2 answers here, and you take the square, you're going to get 2 more answers. Double that, so you end up with 4 answers. So in order to get 2 answers, this must be equal to 0. Okay. So that way you get x squared equal to this. So you take the square root, you get plus or minus, you get 2 answers from here. Okay. So this will equal to 0. Okay. So therefore, so we're gonna just do this part of it. So you got x squared equal to 2k. So it just multiplies. So you got 2k minus 1 over 2. Okay. Again, this has to equal to 0. And again, see, if you take the square root, you get plus or minus, you get 2 answers. Right? Okay. So you got x squared equal to, simplify this, separate this, so you're gonna get k minus 1/2. Okay. Okay. But again, what's x squared? Remember from here, x squared equal to y. Okay. So you got y equal to k minus 1/2. Okay. And so this is the tangent point. Okay. And the center, so over here, the y equal to k minus 1/2. At the center, you got y equal to k. So you can see the difference between the two is 1/2. Okay? Again, over here, the y is k minus 1/2, right? From here, right? At tangent point. Okay. So if you go back over here, so at the tangent point, the y is k minus 1/2. At the center, the y is equal to k. So the difference between it is 1/2. Okay. So again, the difference is k minus 1/2. Okay. So again, so this distance over here, so the distance equal to, the difference is the k minus 1/2. So the difference will equal to 1/2. Okay. So the center will be 1/2 higher than the tangent point for the y value. Okay.